תגיד לי כשאתה מוכן.
אוקיי, יש.
Project management is a combination of art and science. It's the art of team building, motivating people, leadership, and it's the science of scheduling, budgeting, resource management, and risk management. The high rate of failure of projects, about 1/3 is late, 1/3 is over budget, according to the recent PMI 2021 survey, motivated us to develop a tool that will support both the art and science of project management. The tool is based on traditional project management methodologies and add some features and functions. To demonstrate the tool, I will use a very simple example of a new radar development system, where we have 5 activities, as you can see on the screen. And the activities are systems engineering, the transmitter design and building, receiver design and building, antenna design and building, and finally, integration. The way it is presented here is a project network, which is a common way to present project activities. The arrows represent the precedence relations among the activities. There are like 200 different software packages for project management, and most of them are using the traditional project management approach, or what we call the default. If I will click on the default plan, I can see the schedule of the project on the Gantt chart. The Gantt chart was developed by Henry Gantt more than 100 years ago. And it's still in use because it's very simple to use, very convenient. But it's based on some assumptions that it's very important to understand. First of all, each bar represents an activity, a project activity. And the length of the bar is the duration of the activity. So the first activity, systems engineering, takes 7 months. And as you can see, each activity has its duration, and an activity cannot start before its predecessor is started. The first question is it a good plan? And if we look at the project information, we will see that this project has 5 activities and a due date of 16 periods. It also has a target cost of $27,000. Now, on the Gantt chart, we can see that the current duration is 18 periods. So this plan, at least from the scheduling point of view, is not a good one. And there is a big question. How do we know that the first activity will take 7 periods, et cetera, et cetera? Well, we don't know. This is an estimate. And this estimate is typically based on the experience and expertise of the people participating in the project. But based on current research, the major reason for project failure is poor estimates. And what we need to do is to improve our estimates. The first thing to do is to move from a single point estimate, the duration is 7 periods, into what's known as the 3-point estimate, a minimum duration for the activity, a most likely duration, and a maximum duration. By doing so, we can get a feeling for the risk involved. How accurate is our estimate? And the second thing we want to do is to ask ourselves, is there a way to shorten the project duration? In order to do that, we will use the critical path method developed in the 1960s we simply click on critical tasks, and we can see that the longest sequence connecting the project start to its end has a duration of 18 months. And in order to reduce the project duration, we must reduce the duration of some critical activities. In traditional project management, this is called project crashing. And typically, the project team will try to add resources in order to reduce the duration of some critical activities. However, in reality, most project activities can be performed in more than one way, either by different combination of resources or by using different technology, or maybe using a subcontractor, etc., etc. So the first thing we want to do is to add the 3-point estimate and to add some more possible ways to perform each activity. If we click on the first activity, we can see that it can be performed in 2 different ways, with a small team and a large team. The most likely duration of a small team is 7 months, as we saw earlier. However, with a large team, we can reduce it to 4 months. The difference between the optimistic duration and pessimistic duration for a small team is quite large. 10 minus 5 is 5 months. However, the range between the pessimistic duration and the optimistic duration for a large team is much smaller. 4 minus 3 is only 2 months. Therefore, the risk associated with a large team is smaller, as our prediction or our estimate is more accurate. Let's switch to a large team. And you can see on the Gantt chart that now the first activity, systems engineering, takes only 4 months. We can reschedule all the preceding activities to start earlier. And if we do that without violating the precedence relation, the project duration is now reduced to 15 months. And the big question is, what is the risk of not finishing the project on time? In order to answer the question, we will use Monte Carlo simulation, and we will simulate the project several times, 10,000 times, and look at the duration chart. And as you can see, the distribution of project duration can now be analyzed, and the probability to finish the project in 15 periods is 79%. And the probability to finish it in 16 periods is 96%. So there is a 4% probability of a project duration larger than the required 16 period, or 4% risk of being late. In a similar way, we can look at the cost chart and remember that our target cost is 27,000. And on the cost chart, we see that the probability to finish the project at a cost of 92,000 is 97%. And actually, the probability to finish it at 27,000 is 100%. So using the Monte Carlo simulation, we can get an idea of how good is our schedule. The question is also whether the schedule is a feasible one. And here we need to look at the different resources performing the project activities. If you click on the first activity again, we will see that we need 2 types of resources, engineers and technicians. And using our tool, we can see how many engineers and how many technicians are required in each period. Currently, we have 2 engineers assigned to the project, it's the blue line, and we need 3 in the first 4 months, and we need 7 in the next 5 months. This is known as resource allocation. It's a traditional project management technique, and actually we can increase the number of engineers in order to accommodate for the number required. We will add 5 more engineers. And we see that now we have enough engineers for the whole project, but some of them will be idle throughout the project. So a better plan will be to adjust the number of engineers exactly to the number required. Actually, what we saw is human intelligence used in order to prepare a project plan. But we can do much better. With machine learning, we can get better estimates of the duration of each activity using deep learning or artificial neural networks. And we can get the best project plans using another type of artificial intelligence, which is reinforcement learning. By doing so, we can find all the solutions that are not dominated for the project, including not only cost, schedule, and risk, but also the benefit or the value the project generates for the stakeholders. Let's do it. I will generate the solutions, and I will have a look at the efficient frontier. And we can see that there are 3 efficient solutions. The first one has a duration of 15 months, a cost of $21,750, and a benefit or value generated of 83%, 1 out of 100. The second one has a duration of 13 months, a cost of $23,450, and a benefit of 80.46. And the last one has a perfect benefit, actually satisfying all the requirements of the stakeholders, but the duration is longer, 15, and the cost is higher. Let's analyze the last solution. We will load it into the system and we'll perform Monte Carlo simulation. If we look at the duration chart now, we'll see that in this solution, the probability to finish in 16 periods is 99%, so it's very high. And the probability to finish within the required cost of 27 is also 100%. So we have a very good solution, much better than the one we developed using Gantt and CPM and resource allocation. This is the advantage of using artificial intelligence and machine learning. Furthermore, project management is not just a science, it's an art. And by using this approach early on in the project, it can help in developing shared understanding among the project team that in many cases did not work together before. Shared understanding is a common agreement about the best schedule, the best plan, the best budget for the project. And if we can generate it, it will help not only team building, but also motivating the project team. Even more, throughout the project lifecycle, most projects suffer from uncertainty and the plans must be changed. Using these tools during the project lifecycle can help the project team and the project manager develop better plans and execute them in a better way. There is a much more to talk about, like the ways those benefits are calculated. In here, it's the function of 3 requirements: the range of the radar system, its quality and its reliability, and a multi-criteria decision-making model that find the value of the proposed plan given its expected results. There is a lot more to say, but in a nutshell, this is the idea we want to propose. Thank you.